So dear student, I Rakesh Jain. Today I am going to teach you about the power amplifier, the basic concept of power amplifier, the basic classification of power amplifier, and how to find out the efficiency in case of power amplifier. So first of all, we just begin. Before that, the prerequisite for this lecture is that what is the basic meaning of power amplifier? Actually, power amplifier raises the power level of the signal. When we say this kind of definition, then there is a word power raises the power level of the signal. Actually, no amplifier can increase the power level of the signal. Actually, the power amplifier converts the DC power into the AC power. So as we say that it raises the power level of the signal. In any audio systems, for example, whenever we speak on a microphone, then the microphone will convert the microphone. So that microphone convert the audio signal or voice signal into electrical signal. That electrical signal will passes from several amplification stages so as to boost the signal level, like the pre-amplifier stage, voltage amplification stages. At last, before applying to the loudspeaker again, so as to convert the electrical signal into sound signal again, just before the loudspeaker, one amplification stage is also there, that is known as power amplification stage. So we can say that power amplifier is actually the last stage of any audio configuration on the audio system. Yeah, power amplifier just applying before before the signal finally applied to the loudspeaker. It actually converts the DC power into the AC power. It actually raises the power level of the signal. So that is the basic meaning of power amplifier. So let begin. First of all, just see this MS Paint file where I'm going to teach you. My audio is connected with this phone, and in my front there is a computer. Okay, so on MS Paint file I'm going to teach you about the power amplifier. So I hope you see this MS Paint file. Yes. So what is the power amplifier? Actually, I'm going to write down the basic definition of the power amplifier. The power amplifier raises the power level of the signal. So it actually raises the power level of the signal, right? So power amplifier is that which increases the power level of the signal. Power amplifier actually converts the DC power into AC power. Power amplifier actually converts DC power into AC output power. Right? For any audio system, the last stage just before the speaker, or we can say loudspeaker. For any audio system, the last stage just before the loudspeaker is power amplification stage. Okay, so these are three basic terms which can easily define the power amplification. What I want to say, let's suppose this is the audio signal. Let's suppose this is the audio signal. Okay, now first the audio signal will be applied on a microphone. So let it be a microphone which converts the audio signal into electrical signal. So let this is the audio signal which is applying on the system, right? And this is the microphone which convert microphone which is mic, we can say. So that microphone will convert the audio signal into the electrical signal. So now here we are applying the electrical signal. Electrical. Now this electrical signal will passes from various stages. Like this is the pre-amplification stage. So I just write down as pre-amplifier. The first amplifier that can I denote here with the name pre-amplifier. Okay. Then it will be passed through several voltage amplification stages. Let's suppose there are two voltage amplification stages. Okay. So let's suppose there are two voltage amplification stages. So this is voltage amplifier. Again there once again there is a voltage amplifier. So here there is also a voltage amplifier. So these are two voltage amplification stage, right? Then before applying to the loudspeaker, before again convert this electrical signal into audio signal, it must passes through a power amplifier. That is our topic. So I just convert this one into another color so you understand. So this is just before applying the loudspeaker. The stage is power amplification stage. Okay. Now after this stage, the signal will be again the electrical signal will be applying to the loudspeaker so as to convert this into electrical signal. So this is my loudspeaker. Okay. Now the signal which will be converted. Now this loudspeaker again convert the electrical signal into the audio signal. So this is actually the voltage amplification stage. This is actually how the audio signal will be passes from the microphone and then again it will be boosted via the loudspeaker. In between that loudspeaker and microphone, there are several amplification stages to raise the voltage level, signal level, power level of the signal. And that voltage amplification stages are voltage amplifier, and to raise the power level of the signal, it means to convert the DC power into the appropriate AC power, we need a power amplifier. So this is the power amplification basics. Now, what is the basic differences between a voltage amplifier and a power amplifier? So I am going to write down the differences between voltage amplifier and power amplifier. What is the basic differences between a voltage amplifier and power amplifier? So just to see this. Okay. Now there are so many differences between a voltage amplifier and power amplifier. Let it be a voltage amplifier. And at the right side, I am going to write down about the power amplifier. Okay, and at the left side, I just write down the parameter on which I am going to differentiate them. Parameter, or we can say parameter. Okay. Yes. So now we begin our journey that how they are different from each other. The first parameter is the current gain beta. The current gain beta. Okay. In case of voltage amplifier, the current gain beta is very high. It is approximately greater than 100. It is approximately greater than 100. Okay. But in case of power amplifier, it is low, approximately 5 to 20. It is low, approximately 5 to 20. Okay. So this is the first parameter which is different in between voltage amplifier and a power amplifier. The second one is the collector resistance that can be denoted by RC. So I am just write down RC here, the collector resistance. Okay. So in case of voltage amplifier, it is very high. It is 4 to 10 kilo, 4 to 10 kilo. But in case of power amplifier, this is low, 5 to 20 ohm only. Only 5 to 20 ohm. So collector resistance is also high in case of voltage amplifier. Okay. Output impedance in case of voltage amplifier is also high. It is 12 kilo. It is approximately 12 kilo. And in case of power amplifier, it is low. It is low, and it is approximately equal to in case of power amplifier, the uh, output impedance is also low, such that the output impedance of maybe 200 ohm, maybe approximately equal to 200 ohm. Now, there are some factors in which the power amplifier is very high. For example, coupling. This is the most important difference between a voltage amplifier and a power amplifier, that the coupling which we employs in voltage amplifier is of resistive capacitive coupling, that is RC coupling. But in case of power amplifier, the coupling which we employ is impedance coupling. Impedance coupling. The next thing is input voltage. Input voltage, we can say input. So in case of voltage amplifier, the input is low. The input is low. It is of few millivolt. It is of few millivolt. Few millivolt. But in case of power amplifier, the input is high. It is 2 to 4 volt. Right? So there are some parametric difference. To create some space, I just remove over here to just remove this parameter. Understand now, to create some space. Okay. Now, so that is high in case of voltage amplifier, and that is low in case of power amplifier. Now we have to see that some other, the collector current is also differ. The collector current is also differ in case of voltage amplifier and power amplifier, such that collector current that can be denoted by IC. So collector current in case of voltage amplifier is low, that is of few millivolt, few milliampere. But in case of power amplifier, greater than 100 milliampere. Greater than 100 milliampere. So this is also difference. The another difference is that voltage amplification stages first employs, then just before the loudspeaker voltage power amplification stage will be there. Voltage amplification stages can amplify the voltage level of the signal, can raise the voltage level of the signal. But power amplification stages raises the power level of the signals. So there are so many differences also. So these are the basic difference between a voltage amplifier and a power amplifier. These are basic differences between a voltage amplifier and a power amplifier. Now we are going to do the how many types of power amplifiers are there. So I just save this MS Paint file, and then we'll open series file amplifier. So basically, the power amplifier can be classified on the basis of frequency used and on the basis of mode of operation. So they can be classified into two major categories. One is on the basis of frequency used, on the basis of frequency, and the second one is on the basis of mode of operation. Yes. So they can be classified into two categories. One is on the basis of signal frequency used in that for amplification in that amplifier, and second one is on the basis of mode of operations. Now, what is the classification on the basis of frequency? So there are two kind of power amplifier. One is audio power amplifier and the second one is radio power amplifier. Audio power amplifier and radio power amplifier. And the second one is radio power amplifier. Yes. And on the basis of mode of operation, they can be classified as class A, class B amplifier, class C amplifier, and one more category is there, that is that actually consists the applications of the class A and advantages of class B held together, that is class AB. Otherwise, they generally can be classified into three major categories. That is class A power amplifier, class B power amplifier, and class C power amplifier. Then class B, and the third one is class C. So what is the meaning of this categorization? Audio power amplifier means those power amplifier which can raises the, I just write down here, basic meaning of those. What is the meaning of audio power amplifier? The meaning of audio power amplifier is that which those power amplifier which raises the power level of the signal in the audio amplification frequency range, that is 20 Hz to 20 kilohertz. Power amplifier which raises means to increase, raises the power level of the signal in frequency range (20 Hz to 20 kilohertz). So that is in power amplifier which raises the power level of the signal in the frequency range 20 Hz to 20 kilohertz are known as audio power amplifier. Okay. Now, what is the radio power amplifier? Radio power amplifier, similar to the classification of audio power amplifier. The radio power amplifier are those which raises the power level of the signal in the frequency range of radio frequency range. And what is the radio frequency range? 3 Hz to 300 gigahertz. So those power amplifier which raises the power level of the signal in frequency range of radio frequency range, that is 3 kilohertz to 300 gigahertz. So that is known as radio power amplifier. Okay. Now, on the basis of mode of operation, what is the meaning of class A power amplifier, class B power amplifier, and class C power amplifier? Now, what is the meaning of class A power amplifier? Class A power amplifier are those power amplifier in which the collector current flows for the full cycle of the input signal. Class B power amplifier is that amplifier in which the collector current flows for only the positive half cycle of the input signal. And class C power amplifier are those power amplifier in which the collector current flows even less than a half cycle. Okay, so class A, and we will see later on that how only the for the positive half cycle the collector current flows in class B. We will prove that. Okay, so what is the class A power amplifier? So, class A power amplifier are those which in which the collector current flows for full cycle of the input signal. Right? Class A power amplifier are those in which the collector current flows for full cycle of the input signal. Yeah, during the full cycle of the input signal. Okay, when the collector current flows at all times we can say. Okay, sorry, at all times. That is the class B power, and when the collector current flows only during the positive half cycle of the input signal. So class A power amplifier are those in which the collector current flows during the full cycle of the input signal. 4K in instead of pure should write down during the full cycle of input signal. Full cycle of right. Now what is the class B power amplifier? We just see. This is class A power amplifier. Now what is the class B power amplifier? Instead of A, I am going to write down here B. So what is the class B power amplifier? So the class B power amplifier are those in which instead of A we should write down class B. So class B power amplifier are those in which the collector current flows only during the positive half cycle of the input signal. During the positive half cycle of the input signal. During the positive half cycle of the input signal. Okay, so this is class B power amplifier. That class B power amplifier is that power amplifier in which the collector current flows during the positive half cycle of the input signal. And now what is the class C power amplifier? So class C amplifier is similar to this. I just create some space, so little bit shift that up. Okay, now what is the class C power amplifier? Class C power amplifier is that power amplifier class C power amplifier are those in which the collector current flows in which the collector current flows for less than half cycle of the input signal. Right. So this is the class A, class B, and class C power amplifier can be classified in various categories on the basis of frequency based on what kind of signal level they are going to increase, like in audio frequency range or in radio frequency range. So that actually in different categories like class A, class B. Second category is related with how much if for only the positive side. Now we are going to say There are so many different the a 5%, and for class C it is 100. So now I okay. Before that, there are some performance consideration parameters. There are some parameters which should be known by everyone before the analyzing the power. So some considering parameters. Considering parameters of power amplifier. So actually there are three parameters which are very important before we go for the detailed study of the power amplifier. The one is the collector efficiency, second one is the power dissipation capacity, and third one is the efficiency. So there are three basic parameters which should be known by everyone before analyzing the power amplifier. So I'm going to write down there are three considering parameters. One is the collector efficiency. The second one is the power dissipation capacity. Power dissipation capacity. And the third one is the distortion. Distortion. Okay. So these three parameters are there. Now, what is the meaning of collector efficiency? It is a collector efficiency is just that we know that the power amplifier convert the DC power into the AC power. So the output AC power, the converted average output AC power divided by the average input DC power multiplied by 100%. It is known as collector efficiency neta. It is actually denoted by neta. Okay. So what is the collector efficiency neta? So collector efficiency neta is actually the output DC output AC power. Okay. In terms of abbreviation, I just write down P is for power. So output AC power divided by input DC power. It is the ratio of the output AC power to input in DC power multiplied by 100%. So that is collector efficiency in percentage. So that is known as the collector efficiency for a power amplifier. Now, what is the power dissipation capacity? You need to understand very clearly, because we know that power amplifier has to increase the power level of the signal, has to raise the power level of the signal, so that simple transistor cannot be used for this purpose. Power transistors are used for this purpose, because those power transistor has to handle much more amount of current, so they get heated up. They will be heated up. So to dissipate that amount of heat, if we do not dissipate that amount of heat, then definitely the operating point of that transistor will be changes. So it will be a drawback. So definitely, to maintain the operating point stable, we need to dissipate the heat. That is known as power dissipation capacity. With the help of heat sinks, we can do this. The third one is distortion. The meaning of distortion is, we know that transistor is a non-linear device. So definitely the output curve of the power amplifier and the input signal will be phase up, maybe in some phase difference. So the output wave shape is not exactly follows the input wave shape. So there is some difference between the output wave shape and the input wave shape. So that is known as distortion. Okay. Once again, I'm going to repeat these considering parameters, performance parameters of power amplifier. These are known as performance parameters also. So I'm going to write down also the name performance parameter. So what are the performance parameter of a power amplifier? Collector efficiency means how much amount of power, the DC power, will be converted into the output AC power. So it is actually the ratio of output DC power to output AC power to input DC power in percentage. So we multiply with 100. So that is known as collector efficiency. In case of class A power amplifier, the collector efficiency is 50%. In case of class B power amplifier, the collector efficiency is 78.5%. We will prove them. In case of class C power amplifier, it is nearly 100%. Okay. Second one is power dissipation capacity. Because in power amplifier, the power amplifier has to handle much more amount of current so as to raise the power level of the signal. To handle much more amount of current, instead of simple transistor, we use the power transistor. Due to excess value of current, the transistor will be heated up so as the operating point will be changes. To maintain the operating point stable, we has to dissipate the large amount of heat. So with the help of heat sink, we can do this. Okay. So that is known as power dissipation capacity. Third one is distortion. The third performance parameter of a power amplifier is the distortion. The meaning of distortion is due to some non-linearity, due to some unwanted signals, there is some changes of the shape in output compared with the input. So the change in output wave shape in compare with the input wave shape, that is known as the distortion. That is known as actually the distortion. Okay, because the transistor is a non-linear device. Okay, so there is some variation in the output compared with the input. So these are the performance parameter of a power amplifier. These are performance parameter of a power amplifier. Now we are going to prove that how in class A power amplifier the collector efficiency is 50%. So I just save this MS Paint file and we start a new MS Paint file. Okay. So now class A power amplifier. Prove that in class A power amplifier, the collector efficiency is 50%. So class A power amplifier. Okay. So first of all, you should know various things about the class A power amplifier. How you can create your notes? Yeah, how can you can remember the class A power amplifier? Like because it is a power amplifier, so definitely it raises the power level of the signal. Because it is a power amplifier, that's why it will convert the DC power into the output AC power. Because it is a power amplifier, so definitely the input signal is high, the collector current will be high, the output impedance will be low, the current gain beta will be low, the collector resistance RB will be low, and the coupling which we will employ is definitely the transformer coupling. So definitely these total can be a term of any power amplifier. So these term can be written in class A power amplifier also. Instead of that, then on the basis of classification, we can say class A power amplifier is that power amplifier. Class A power amplifier is that power amplifier in which the collector current flows for the full cycle of input signal. During the full cycle of the collector current flows during the full cycle of input signal. Class A power amplifier is that power amplifier in which the collector current flows during the full cycle of the input signal. The second thing is the collector efficiency of class A power amplifier. Collector efficiency of class A power amplifier is 50%, and we will prove that. Okay, the collector efficiency for a class A power amplifier will be 50%. Okay, generally the class A each power amplifier uses for a different purpose. For example, class C power amplifier is generally instead for power amplification that will be used in tuned amplification. Okay, for the class A power amplifier, actually this class A power amplifier is actually used for impedance matching as a driver amplifier. Okay, I just write down actually class A power amplifier is used for the impedance matching. Class A power amplifier uses transformer coupling. It is because it is a power amplifier, so it uses transformer coupling, and the main application of class A power amplifier is impedance matching. Class A power amplifier is generally used for impedance matching. Okay, it can also be used as a driver amplifier. So this is the applications. Okay, now first of all, how the circuit diagram of a class A power amplifier will be looks like. So I am going to write down, because there are two terms. One is the coupling and second one is the amplification stage. It is an amplifier. Okay, so for the amplification we use transistors, and for the coupling we use a transformer. So see the basic circuit diagram of a class A power amplifier. Class A power amplifier. Now this is the circuit diagram of a class A power amplifier. This is an NPN transistor. At the collector side from where we will taken out the output, the transformer will be used. Because transformer coupling we employ. At the secondary of the transformer, the load resistance will be connected. And this side will be connected to the VCC. And this is the resistance R1. This one will be the resistance R2. With the help of the capacitor, we apply the input to the base of the transistor. And here resistance RE and C is connected. Here we apply the input. Okay, due to that load, the reflected load will be at this place. Here will be the reflected load RL dash. Because the load is RL, so it can be known as RL dash. It is the reflected. So this is the basic circuit diagram of a class A power amplifier. This R1 and R2 resistance, provide the voltage divider arrangement, The resistance, the capacitor CE is a bypass capacitor, and RE is to prevent the AC voltage. The transformer is a step down transformer. Okay. This R1 and R2 for the potential divider arrangement. C is the bypass capacitor, right? RE is just used to prevent the AC voltages, right? So this is the basic circuit diagram of power amplifier. I am going to write down the basic term. R1 and R2 are used to provide potential divider arrangement. Okay. C is in subscript, so I decrease this size. Okay, now it will clear. C is bypass capacitor. Bypass capacitor, and RE is resistance. RE is to prevent the AC voltage. Is to prevent the this is the basic circuitry of this class A power amplifier. The transformer is a step down transformer. Okay. Now, because it is used as a impedance matching. Now, what is the meaning of impedance matching? As we know that in a transformer, the turn ratio is V1 upon V2 is equal to N1 upon N2 is equal to I2 upon I1. Okay. So, what is the reflected or what is the meaning of this one? Just to see here. What is the impedance matching? How the reflected load will be there. It means, okay. So, in a transformer, we know that, let's suppose this is a transformer. Okay. Okay, in which the input voltage is V1, input current is, let's suppose, I1. Okay, the output voltage is V2. Output means the secondary voltage I am going to give you. Okay, the current, the load is RL. Let's suppose the load is RL. The voltage is V2. The load is RL. Let's suppose there is a resistance whose value is RL. Across this resistance, the voltage at the secondary is V2. The primary winding voltage is V1. The current is I1. Due to this, the reflected load will becomes how? Because we know that turn ratio in the transformer formula. What is the turn ratio? Turn ratio in the transformer is actually equal, is actually termed as this one. V1 upon V2 means primary voltage divided by secondary voltage is exactly equal to the number of turn in primary divided by number of turn in the secondary. Okay, it can also be known as the current. This is equation number 1. Okay, now the equation number 1 is the current in the secondary divided by current in the primary. It is also equal to the same number of turns in the primary divided by number of turns in the secondary. So from these two equations, we have to find out that what is the impedance, reflected impedance at the input. So from this, what is the value of V1? From the equation number first, what is the value of V1? See, what is V1? So V1 is exactly equal to N1 divided by N2 multiplied by V2. Okay. Now from this equation, what is I1? See, what is I1? I1 is equal to N2, because this I have to find out this I1 value. So I1 is exactly equal to N2 upon N1. N2 upon N1. This is N2, not a neta sign. Okay, N2 upon N1. N2 upon N1 multiplied by I2. Okay. So what we from these two, what is the V1 upon I1? Means V upon I is known as resistance or impedance. So what is V1 upon I1? So N1 upon N2 divided by N2 upon N1. So it will be square of N1 upon N2. It will converted into a square of N1 upon N2. Then V2 upon I2. So what is this finally? V1 upon I1 is known as reflected load RL dash. Okay, is equal to N1 upon N2 can be termed as a turn ratio. So N we can denote as N. So N square. N means N1 upon N2. And V2 upon I2 means the load RL. So this is the reflected load RL dash here. This is the reflected load RL dash here. Okay, which is denoted in this diagram by this. So RL dash is equal to N square RL. So this is impedance matching. Now we have to prove. Now I am going to delete this and we have to prove the basic derivation for the collector efficiency in case of class E. Okay, in the same page I am going to write out. No, in the new page. Okay, wait for a while. Now we have to prove the collector efficiency formula for the class E power amplifier. So see, collector efficiency class A power amplifier. Now we are going to prove what is the how the collector efficiency is 50%, which I have already been taught you that class A power amplifier collector efficiency is 50%. So now we have to prove. So the remaining term I remove and then we will start. This is the circuit diagram of a class A power amplifier in which we see that the capacitor C is a bypass capacitor. RE is used for the purpose of prevent the AC voltages. R1 and R2 forms the voltage dividation arrangement. RL dash will be generated due to the impedance matching concept. Okay. Now in this, the voltage which will be I denote is by the VCC. Okay. And the current which I will denote will be IC. Okay. Or we can say ICQ, that is operating point collectors. Okay. Now we have to find out the collector efficiency. And we know that collector efficiency neta is given as output AC power divided by input DC power multiplied by 100%. Okay. So we have to find out the collector efficiency. Sorry, the collector efficiency for a class A power amplifier. Now see, what is the input DC power? Power can be termed as the multiplication of voltage multiplied by current. So here, just put the voltage as DC battery voltage VCC and the current as the current flowing through the collector, that is collector current IC. So this is equation number 1, that is input DC power. Now what is the AC output power? So the AC output power can also be termed as voltage multiplied by current, but because this is of AC, so voltage is not the simple voltage, it is actually the root mean square voltage of voltage, and the current is the not simple current, it is actually the root mean square value of the current. Okay, and how the voltage and current can be termed as a root mean square value? So the voltage is VCC. When it will be divided by root 2 term, it will be converted, it will be known as a RMS value of voltage. Definitely the current, which is IC actually, whenever it will be divided by root 2, then definitely it will be RMS value of the current. So this is equation number 2. Okay, or we can say, oh, sorry, or we can say VCC multiply by IC, that is VCC, multiply by IC, divided by root 2 multiply by root 2. So root 2 when multiply by root 2, it will be equal to 2. So this is equation number second. Okay. So what is the collector efficiency? So the collector efficiency is equation number 2 divided by equation number 1. So VCC to VCC will be cancelled out. What I want to say, just to see, this is equation number 2, that is AC power divided by, so there is a sign of division, DC power. So what is DC power? VCC and IC is the DC power. Multiply by 100. So it will be multiplied by 100 for percentage. So now this VCC to IC term to VCC IT term will be cancelled out. Only 1 divided by 2 will be remain and multiply by 100%. So it will be 50%. So it will be 50%. So we prove that the collector efficiency of a class A power amplifier is 50%. So I hope you understand about the class A power amplifier basics, its applications, impedance matching concept, how the amplification is 50%, and the basics of the power amplifier. So I, Rakesh Jain, want to say you thanks for watching the video. Kindly like and subscribe the video. Thank you. Thank you very much.